Okay, welcome back, physics fans. Number one on the conservation of momentum, conservation of energy. A 100 kilogram roller coaster is traveling at 22 meters per second. If the car starts out at a height of 12 meters, how fast will the car be traveling when it gets down to ground level? Ignore friction. So we have the car up high on level ground, and then it goes down a slope. And the height that it loses here is 12 meters. The car up at the top is moving at 22 meters per second. This is one heck of a roller coaster. It's nice. And we want to know how fast it's going down at the bottom. This is the final. So V final is what they're asking. So we're going to set the potential energy to be zero at the bottom. Potential energy will be zero at the bottom. And then we get to figure out exactly about what the kinetic energy is at the end. So up here, what I left up here is a good ultimate conservation of energy formula. The energy before, in both the potential and kinetic, plus how much is added to it from outside. Well, there's nothing in this question that's being added. There's no push, there's no rocket adding energy to it. So this doesn't exist. Then at the end is potential energy final, kinetic energy final, and heat. But there is no friction, so there won't be any heat. So the energy before equals the energy after, and the energy before is potential energy initial plus kinetic energy initial has to equal the energy at the end, potential energy final plus the kinetic energy final. There is no heat, so I won't put the heat in. So else you would put down the heat there if there was friction and stuff like that, but we're not going to put that in there. So we'll not, and there's no push and shove. So there's no spring energy in here. This is just mgh plus 1 half mv squared, and that's the initial speed. And this is zero because we've set the potential energy to be zero at the end. And plus the kinetic energy is 1 half mvf squared. Now, if you're a mathematical person and taking a look at it, you'll see that every term here has an m in it, so you could cancel it out so that m is everywhere. But be careful about doing that. If as soon as there's heat or energy added in and it's in joules, we can't cancel out the m's. We can't. So on the safe side, I won't cancel out the m's here. And by doing so, if we leave the m's in, then the numbers that we get for mgh will actually be its energy. If we cancel out the m's, it's going to be the energy per kilogram, and that's not a weird. That's a weird unit. So mass is 100, g is 9.8, the height of this is 12 meters, and I'm going to change color here to kinetic energy plus 1 half. The mass is 100 kilograms, and the velocity here is 22 meters. Where do people go wrong? This is where people go wrong. They forget to square that 22. And that has to equal 1 half, the mass is 100, and VF squared. So out comes Mr. Calculator. Let's bring it over here. And we get 100 times 9.8 times 12. That'll be in joules, the potential energy beforehand. 11,760 joules. Plus the kinetic energy, 0.5 times 100, which is 50, times 22 squared, 484, 242. So 242, 24,220, 200. That's the joules. And that has to equal 1 half 100 VF squared. So that's 50 VF squared. Let's just add these two numbers together. That's an important number. What is it when we add these this number and this number together, those two numbers? That'll be the total energy. So I'm just going to go to black here. The total energy is 35960 joules is equal to 50 VF. That's pretty cool. If we cancel out the M's, we would have it without M in there, and it'd be 100 less because it's 100, but that wouldn't be the joules. It would be joules per kilogram. It'd be a weird number. So we now divide this by 50 and square root it, and we'll get the answer 26.82. VF is 26.82 meters per second. Okay, so the auxiliary question at the end here, what about the angle of the slope? Would this also be true if we had done a roller coaster that went like this? It still went down 12 meters, but the roller coaster went down not as steep of a hill. What about that? Would it be the same? Would it be different? Would it be slower? Because, of course, it's definitely not picking up the same speed as it falls here. Or is it? Answer in your comments below. Like this question. Subscribe.